Good morning, guys, and welcome back to Dynamics course. In this lecture, we're going to start solving the problems about impulse and momentum, chapter 15, and especially about the theory of impulse and momentum, which is in fact the momentum at 1 plus the sum of the linear impulse of all the forces exerted on a body is equal to the momentum at state 2. So let's start by solving example 1. In example 1, I have 200 kilograms crate that is resting on the ground for which the coefficients of static and kinetic friction. So I have here static and kinetic friction, and as we know from previous video lectures, if I have two friction coefficient, I should first of all, the first step ever is to find the time required to move this body, and this could be determined by considering the equilibrium on this body. Right, so by considering the static and by applying the first law of Newton. Now I know that this winch is delivering a horizontal towing force T to its cable at A here. So of course I have this 2T here, and these 2T are exerted on this crate right here. But this T is varying as shown in this graph, and it's equal to 400T to the power 1 over 2 starting from 0. Right? So I need, in fact, to determine the speed of this crate when t is equal to 4 by, of course, applying the principle of linear impulse and momentum. So as we said, we have to start first by finding the time required to move the crate, and this can be determined by considering the equilibrium of this crate. Now, since I know what are the forces exerted on this crate, and especially the towing force T that is in function of time, I can find this time required to move the crate. So let's start. I'm going to first, in fact, start by drawing the forces or the free body diagram of this crate. So what do you think are the forces exerted on this crate? Of course, I have the weight because I know the mass. So I have the weight. I have, of course, the normal force. And since I know the static and kinetic friction, this means that I have a frictional force. And since this is towing force here is given to the right, of course, this crate will move to the right, and then the frictional force is to the left. So this is my frictional force. It's horizontal, and it's equal to mu times n. Now this mu could be mu s times n or mu k times n depending on the state. I have to start first by the static case to find the time required, and then I can move to the dynamic case to find and use mu k to find, in fact, some unknown so that I can find the velocity at state 2. Now, what are the forces exerted on this crate? Also, I have 2t. Alright, so this is the first T and this is the second T. Now guys, I know that you can think of this crate as your free body diagram, and then you have to consider this force here, but don't forget guys that this force here is equal to 2t because the pulley is always in static. All right, so this force here t, this tension force should be equal to 2t because the pulley is in static. Or since the mass of pulley is always neglected, I can take this as my free body diagram. So the crate with this pulley, and then in this case these 2t will be shown, and this force here will be internal. Alright, so as I said, I have the normal force, the weight, the frictional force, and I have two tensions. First of all, I have to consider the static case, and in this case the frictional force will be equal to mu s times n. So the frictional force in static will be equal to mu s, which is here equal to 0.45 times n. So I should find n. So what is n? Or how to find n? Of course, guys, n could be found by using Newton's first law in y direction, alright? So sum of forces in y direction will be equal to 0. And in this case, n minus the weight is equal to 0, and then n is equal to the weight, and the weight will be equal to 200, the mass times the gravity, alright? So n will be equal to 1962 Newton. right? So once I know n, I can apply the sum of fx is equal to 0 in static case, all right? The sum of fx is equal to 0, and then this will give me 2t, if I take this x as positive direction, 2t minus the frictional force in static is equal to 0, and this will give me the time needed or required to move the crate, right? So 2t, and t is equal to 400 t to the power 1 over 2 minus the frictional force in static, which is 0.5 times n, and n here is 1962. In fact, n is always 1962. It's the opposite of the weight, and this will be equal to 0. And then, sorry, this will give me the time t as 1.5 seconds, all right? So now I know the time t as 1.5 seconds. I can start from this time here to the dynamic case, right? So I can start from this time to the dynamic case, right? Don't forget, guys, that the question is to find the velocity at t is equal to 4. Now, of course, there is a lot of methods to find this velocity. You can, of course, apply, for example, the work energy principle, all right? So I can apply T1 plus sum of work of all the forces equal to T2, especially that I know that the velocity at state 1 is equal to 0, because from this sentence, the 200 kilogram crate rests on the ground, right? So at the first state, the velocity was 0, all right? But you cannot apply the sum, you cannot apply the conservation of mechanical energy, because remember, you have a frictional force here, all right? So let's now apply the principle of impulse and momentum, which is in fact this chapter. So I have to apply the principle of impulse and momentum in order to find V2. Okay. So what does this principle illustrates? In fact, it illustrates the variation of momentum in terms of the impulse of forces. So I know that the momentum at state 1 plus the sum of the linear impulse, which is given by the integration between T1 and T2. The forces, now here I'm going to take x direction, because in fact the motion is in x direction, there is no motion in y direction, all right, is equal to mvx2. And now here, this velocity will of course be equal to 0. Now, what are the forces exerted? I have 2t, and t is equal to 400t to the power 1.1 over 2. And don't forget that this will start from the time 1.5, all right? So this will start in the dynamic case to integration of 1.5 till 4 seconds, because this is the question of 400 t 1 over 2 dt. Right? What are the forces, the remaining forces in x direction? Don't forget that I have the frictional force, and now the frictional force is equal to mu k times n, and mu k is equal here to 0.4. So minus 0.4. Why is it minus? Because in fact it's in the negative direction of x. And don't forget that n will be always the same, in fact, even in dynamic case, because there is no acceleration in y direction. So this crate is not moving in y direction, which means it's always in static in y direction, all right? And then okay, so this is my frictional force times delta t. Now I don't need the integration, because this frictional force is here constant between, of course, 1.5 and 4. So it is T2, which is 4, minus T1, which is 1.5037. and this will be equal to what? To mvx2. Now m is 200 kilograms, and vx2 should be found. So if you do this, you can find vx2 or v2 or v at 4 is equal to 6.621 meters per second. Alright, so you can do the integration by yourself. In fact, what is the integration of 400t to the power 1 over 2? It's 400 t to the power 3 over 2 over 3 over 2. Alright? So that's it. Let's now move to example 2 in this next video. Thank you.